Okay, I guess I do need tail support.
Well, good morning and welcome back to the workshop. Today we're going to be having a look at the MyfordBoy traction engine. Now you might say this is a fairly transparent sulk because the crank axle, the made of Kent, didn't work out exactly as I had planned. But I'd like to say this is a lot of personal growth because generally I'd be thinking about how terrible engineer I am, how I should give up the entire thing. And this time I'm thinking that's just fine, let's just put it over to the side for a minute and try something else. So let's do some more of that traction engine build. Got quite a few parts built already. Let's have a look at those. So this is the MyfordBoy traction engine, and you see today I've made quite a few parts. This is mostly for the engine which sits on top. I made the flywheel over here, this lovely Mazak casting. And so as we look through the documents, the boiler I haven't touched yet, but these sections here, you see I've made these parts already and made a huge amount of them. So I just figured, let's go make a couple more, iterate on this, maybe the valve. I think before anything else though, just because I've got the lathe set up for it, I'm going to make this second shaft here, which is for one of the gear wheels. Got to take this down to 1/4 inch, so it's quite a bit to come off. Let's get doing it. So I've got the same problem as I had last time in that when I'm using the dividing head, which I thought I'd just use for a change, the vertical height is such, especially with the chuck in there, that I don't have enough space for one of the wigglers that I normally use to fit in here. Maybe if I had a very narrow collet chuck, I might just fit it, but I don't really think so. Either way, I've got a 1/4 inch drill bit, and this spigot is a 1/4 inch. I've lined them up, and they're pretty perfectly aligned by eye. I think that's probably going to be good enough. I think I'm transferring through on the holes on this to the sheet metal that will be that this will attach to. So I think this is probably good enough. I do need to figure out a better solution long term though. Two, three, 4, 5, 6, 7, 8. This is a 112 thou hole required, which turns out to be a number 32 drill. This stuff has been machining like an absolute pig, but I don't know if I can face turning all that down. I need only a 1/16 of an inch here, so I'm going to try parting it and see what happens. Just a simple little thing, but job and done. So all this is sheet metal that we haven't got the parts for just yet, but I think this is what we're going to look at now. This is the piston valve made out of some brass. So let's go over to the lathe and get that done. Right, with that tail support in place, let's try again. Now we've done that groove, we need to move across 40 thou, because this is 8 wide and this needs to be 1/8 of an inch. So, well, 45 thou really. So. Now, because we're now on the inside of this cut, we need to move 80 and then traverse the 340. The most difficult thing for me when I'm remembering this is which side of the blade I'm measuring my distances from. So from the chuck side of this groove, which is where I started, I needed to move across to the distance plus the thickness of the blade, which meant I'm measuring from this side of the blade. Now I've switched, I'm measuring from the center side of the blade. So then when I traverse across, I have to reduce that dimension by the thickness of the blade, because the blade is going to be 80 thou away from the point I'm measuring it. So I need to move it across 264 thou instead of 340, because if I did, that would be 340 plus the thickness of the blade, which would be wrong. So now I'm on this side of the blade again. I now need to move 340 plus the thickness of the blade. Now, parting off, need to switch sides of the blades again. So 80 plus the 650 that it needs to be before I part it off. You're looking at this setup and thinking, what the heck is he doing turning between centers? I'm not. I messed up the end of the piston valve, so now I'm gluing another plug in and I'll try again. This may seem like an odd choice. I have a ball nose end mill here, or ball nose slot drill in fact, and the idea is to get a little flat surface on this piece here so the drill doesn't wander. Now I don't think it should wander, but there's no harm in doing this just to make sure. There's the completed piston valve. The next piece of work is to machine up a valve chest. a rectangular valve chest from this piece of bar. That is for next episode.